Astronomers at Western University have discovered the most rapidly rotating brown dwarfs known. They found 3 brown dwarfs that each complete a full rotation roughly once every hour. That rate is so extreme that if these failed stars rotated any faster, they could come close to tearing themselves apart. Identified by NASA's Spitzer space telescope. The brown dwarfs were then studied by ground-based telescopes including Gemini North, which confirmed their surprisingly speedy rotation. 3 brown dwarfs have been discovered spinning faster than any other found before. Astronomers at Western University in Canada first measured the rotation speeds of these brown dwarfs using NASA's Spitzer Space Telescope and confirmed them with follow-up observations with the Gemini North telescope on Maunakea in Hawaii and the Carnegie Institution for Science's Magellan Baade telephone. Gemini North is one of the pair of telescopes that make up the International Gemini Observatory, a program of NSF's NOIRLab. "We seem to have come across a speed limit on the rotation of brown dwarfs," said Megan Tannick, the Western University physics and astronomy graduate student who led the discovery. Despite extensive searches, by our own team and others, no brown dwarfs have been found to rotate any faster. In fact, faster spins may lead to a brown dwarf tearing itself apart. Brown dwarfs are, simply put, failed stars. They form like stars but are less massive and more like giant planets. 1. Tannick and Western University astronomer Stanimir Mechev worked with international collaborators to find 3 rapidly rotating brown dwarfs spinning around their axes once every hour. This is approximately 10 times faster than normal. 2. And about 30% faster than the most rapid rotations previously measured in such objects. The astronomers used large ground-based telescopes, Gemini North in Hawaii and Magellan Baade in Chile, to confirm the rapid rotations. They did this by measuring alterations in the brown dwarf's light caused by the Doppler effect and using a computer model to match those alterations to spin rates. 3. The researchers found that these brown dwarfs spin with speeds of about 350,000 km per hour, around 220,000 miles per hour, at their equator, which is 10 times faster than Jupiter. "These unusual brown dwarfs are spinning at dizzying speeds," said Sandy Leggett, an astronomer at Gemini North who studies brown dwarfs. At about 350,000 km per hour, the relatively weak gravity of the brown dwarfs is barely holding them together. This exciting discovery by the Tannick team has identified rotational limits beyond which these objects may not exist. The team first identified the rapid rotation rates by using NASA's Spitzer Space Telescope to measure how quickly the brightness of the objects varied. Brown dwarfs, like planets with atmospheres, can have large weather storms that affect their visible brightness, explained Mechev. The observed brightness variations show how frequently the same storms are seen as the object spins, which reveals the brown dwarf's spin period. The team's results will appear in an upcoming issue of the Astronomical Journal. Notes. 1. There are 4 known giant planets in the Solar System: Jupiter, Saturn, Uranus, and Neptune. 2. Stars, brown dwarfs, and planets generally spin around their axis once every 10 hours or more slowly. For example, Earth spins around its axis once every 24 hours while Jupiter and Saturn take about 10 hours. The Sun spins around its axis on average every 27 days. The Sun's rotation rate varies with latitude, with its equatorial regions completing a rotation in about 25 days and the polar regions rotating once in approximately 35 days. As each brown dwarf rotates, light from the hemisphere turning toward us appears blueshifted while light from the hemisphere turning away from us appears redshifted because of the Doppler effect. This causes absorption lines in the brown dwarf spectrum to appear broadened, stretched both toward the red end of the spectrum and the blue end of the spectrum. By matching this broadening to a computer model, the astronomers determined how fast each brown dwarf is spinning. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.